Given a function, the inverse function basically undoes whatever the function did. But how to find the inverse function? Today, I will show you a few examples. First, let's look at a linear function of x equals 2x plus 2. The blue line is the graph. In order to find the inverse function, first, we replace fx by y. So y equals 2x plus 2. Then we swap x and y. So we get x equals 2y plus 2. Next, we solve y. First, both sides subtract 2. So we get x minus 2 equals 2y. Then, both sides divided by 2. So we get x minus 2 divided by 2 equals y. That is the inverse function. We use inverse x equals x minus 2 divided by 2. We can graph it. So when x equals -2, y equals -2. When x equals 2, y equals 0. So we connect them. So you see the graph of the given function and the graph of the inverse function are symmetric about the yellow line, y equals x. At this point, we should ask, does any function have an inverse? Let's look at a following quadratic function. Gx equals x squared minus 1. You see from the graph, it is not one-to-one function because y equals 0 corresponds to two different x values, -1 and 1. So it does not have an inverse function, but we can confine the domain to positive x or negative x, say positive x. So d equals 0, positive infinity. So you see this branch is a one-to-one function. So we can find the inverse. Again, replace gx by y. So y equals x squared minus 1. Then we swap x and y. So x equals y squared minus 1. To solve y, we add 1 to both sides. So plus 1. So we get x plus 1 equals y squared. To eliminate square, we take square root for both sides. So we get square root of x plus 1 equals square root of y squared, which is y, absolute value y. So y has two expressions, so plus or minus square root of x plus 1. Which one is the right answer? We know the range of the inverse function equal to the domain of the given function. So which is 0, positive, infinity. So in order to make the range non-negative, we should take positive. So the inverse function equals positive square root of x plus 1. Now let's look at a quadratic function. X cubed minus 3 of x equals x cubed minus 3. You see from the graph, it is a one-to-one function. So we can find the inverse. Y equals x cubed minus 3. First, we swap x and y. So x equals y cubed minus 3. To isolate y, we add 3 to both sides. So we get x plus 3 equals y cubed. To eliminate the cube, we take cubic root. So we get cubic root of x plus 3 equals cubic root of y cubed, which is y. So the inverse function is cubic root x plus 3. Finally, let's look at a rational function. Gx equals x squared minus 1 over x squared plus 1. Although it is not one-to-one function, but we can confine the domain, say, domain from negative infinity to 0. We consider this part. So you see the graph is a one-to-one function. So we can find the inverse. Change gx to y. So y equals x squared minus 1 over x squared plus 1. Swap x and y. So we get x equals y squared minus 1 over y squared plus 1. To create the denominator, both sides multiply by y squared plus 1. So we get x times y squared plus 1 equals y squared minus 1. Then we expand the left side. So we get x y squared plus x equals y squared minus 1. To solve y, we move this term to the right side. So we get negative x y squared. Move negative x to the left side to positive x. So we get 1 plus x equals y squared minus xy squared. Then we can factor the right side. Y squared times 1 minus x. Now we can divide both sides by 1 minus x. 1 minus x. So we get 1 plus x over 1 minus x equals y squared. Finally, by taking square root, we get square root of 1 plus x over 1 minus x. Remember, plus and minus equals y. To see which one is the right answer, again, because the range of the inverse function equals the domain of the given function, which is negative infinity 0. So to make the range of the inverse function as negative, we should take negative. So the inverse function gx equals negative square root of 1 plus x over 1 minus x. That's all for this video.